Today we welcome Andrew Waugh, who's the founding director of Waugh Thistleton Architects. They're a practice that are particularly well known for being a long-standing advocate of timber as a sustainable alternative to conventional building materials. Andrew's going to be talking to us about the black and white building. Perhaps you can tell us why it's called the black and white building for a start, which is a case study of a boundary-pushing sustainable workspace. So before I ask Andrew to introduce himself, can I just remind you to keep your mics on mute? This is going to be a slightly shorter session because Andrew has another appointment to get to. So we're going to have a hard cut off at 12:45. With that in mind, Andrew's still happy to receive questions throughout the presentation. So if there are any questions, please post them in the chat and I'll interrupt Andrew accordingly. So yeah, Andrew, thank you very much. Thanks for coming along. Thanks for talking to us today. I'll hand over to you.
Great, thanks a lot. So hi everybody, afternoon. I'm Andrew Waugh from Waugh Thistleton Architects, and we've been going about 26 years. We're a studio based in London, and for the last I guess about the last 18 years or so, an increasing part of the practice's focus has been around hasn't been around. It's been adopting, I guess, an increased level of understanding about the implications that our industry, that the construction industry has on the climate emergency, and our responsibility and duty within the industry to act as thought leaders in order to talk about how we can reduce those carbon emissions, how we can reduce the reliance on precious planetary resources, how we can make buildings that are responsive to climate and to context, and how we can do all of that within the kind of framework of successful architecture. And I like to start with this slide because I just want to illustrate that climate emergency is here and now. The climate emergency is mass migration and Donald Trump and sewage in our waterways and everything else. And it is upon us, and we need to act rapidly. The built environment is a major contributor to greenhouse gas emissions, and in fact, construction, probably in the UK, about 25% of our emissions are purely down to construction and the process of construction, the materials that we use. And you know, this is not a new conversation. In fact, the last 60 years we've been talking about this, and for a typical apartment building over 60 years, you know, in the 70s, that was really all about operational carbon. So over 60 years, you know, sort of 3/5 of that, 60% of that was really all about the operational carbon. So the heating, the lighting, the air conditioning of those buildings, and say 20% odd was around the construction. And we got better at that. So by the 2000s, we had really reduced that operational carbon down, and we'd increased the burden by doing that of the construction emissions that produce making buildings, because we started to put in insulation and double glazing, which is how we got these incredible kind of operational carbon savings. And in doing that, really, you know, we started to look for other low-hanging fruit, if you like, for how we can improve our buildings. And that has come primarily from the energy frame. So thinking about solar panels and ground source energy and neighborhood generation systems and those sorts of things, wind turbines, etc. And you know, over the last 20 years, we have driven that right down. And so a contemporary building that responds to or adheres to building regulations, Part L, etc., that actually is a low carbon, low operational carbon building, a tiny proportion of that building's carbon over its lifetime is now down to the operational carbon. And yet more than half is down to construction and to the choices largely of the architects and engineers who go to make those buildings. And yet this is not something that we speak about. This is not something that it makes up part of the frame of success for our buildings, and not something that, in the UK at least, not something that is legislated at all. And so we see buildings such as this amazing building by Foster's being given awards, being given the Sterling Prize on the basis of sustainability. And yet actually, you know, we were told by the services engineer that the £100 million that they spent on this building, taking it from a building regulation compliant building to a LEED platinum BREEAM absolutely incredible type of building, that £100 million could have been saved if they put a poster up outside the front door that in the wintertime said, put a jumper on, and in the summertime said, take your jacket off. And these buildings, the embodied carbon of our buildings, the tall buildings that we're building in order to have some notions of density around our buildings, around our sites, the idea that we can build super tall in timber and somehow store massive amounts of carbon really is the other end of the spectrum of, of thinking about how we can address the climate issues, the carbon issues of construction and architecture by building massively in timber. And I think that what we need to do is that, the excess of the of reducing operational carbon demonstrated in the Bloomberg and the excess of embodied carbon conversation demonstrated by super tall timber buildings are not dissimilar. Because actually the truth is that what we need to do is to make smaller, simpler buildings from bio-based materials. And that we need to reframe notions of success in architecture away from the tallest and the glitziest to actually the buildings that make people or allow people to be the happiest, to be the healthiest, and for our cities to feel as though they are a kind of a joined up constant conversation of architecture and of society's needs rather than individual idea explosions. And we started really this journey in essence in 2008 with I think it was our third or fourth mass timber project, CLT project called Murray Grove in Shoreditch, which was a 9-storey building, for Metropolitan Housing Trust, a housing association, which is 29 apartments, excuse me, 9 stories, over 1,000 tons of CO2 stored within the material of the building. Very fast, very efficient, very precise process. 27 days, no jackhammers, no grinders, no cement mixers, all built with cordless screwdrivers, and no tower crane. So everything done from the back of a mobile crane. And you can see the adjacent buildings, the closest sitting rooms to the building site are about 8 or 9 meters away. And we didn't have a single complaint during the whole build process. And that building is a honeycomb. So it really, every piece of CLT, every piece of cross-laminated timber in that building working really hard. So the external walls, the internal walls, the floor slabs, staircases, lift shafts, everything made of timber. And you can see inside here really simple details. I mean, 15 years ago when we were first working in cross-laminated timber, you had 2 different types of cross-laminated timber. You had thick one and a thin one, and that was it. And so it was a very kind of rudimentary process. You put in as much timber as you could, and you fix the whole thing together with a 75 mil galvanized angle bracket and a 100 mil screw. And you can see the whole building here is detailed that simply. And on the soffit here, you can see of the slab, these little plastic tags which took all the services. So very fast, very accurate process. So much less waste because of the prefabrication, because everything arrives on the back of a truck, cut to site, plus or minus a few millimeters, a couple of millimeters. So much less waste. So hardly a skip taken from site in terms of site waste. Far fewer deliveries, about an 80% reduction in traffic. Even though we were importing the material from Austria to build a building, to build the main structure of the building, it was still a vast reduction in terms of deliveries to site. And lightweight, so the building itself weighs around 20%, the structure weighs around 20% of an equivalent concrete structure. So the implications of that for transport, but also for reduced foundation, etc., are a very important part of that. And it's still there. Every Saturday morning, I cycle past it with my daughter on our way to swimming lessons, and so still standing and still a successful piece of architecture, I feel. And we had a lot of interest in the building, I think, really to our surprise, and so we decided that we could go one of 2 ways as a practice, really, that we could kind of keep this information to ourselves and have this sort of branded technology way of building, or we could talk about it to everybody who would listen, and every opportunity to talk about it, to share drawings, to share information, to share learning. And that really has been a kind of, I guess, a sort of a foundation of the kind of core ethos of the project, is that understanding that what we are doing is a collaborative effort, and that what we want to do is to engage in conversation within our industry in order to encourage other people. We think encourage other people to build in mass timber, to build in CLT, to share learnings in a new way of thinking about architecture, but also to really engage in conversation around how we see the success of architecture, how we see the responsibilities of architecture on a greater scale. And so that book has been followed up by many pieces of research. About 20% of our turnover as a practice is pure research. We've just finished this piece for the Timber Development UK, who's a timber promotional agency, and that's based on timber typologies around different types of construction, from timber frame to closed panel construction to mass timber to policy, how local governments and national governments can adopt policies from elsewhere in the world which promote the use of mass timber and other bio-based materials, and help local authorities begin to talk about embodied carbon as an important part of a carbon reduction process. And then how we measure that, how we actually understand the life cycle assessments of timber, and how we can employ those metrics to begin to help us all really understand how we measure, how we quantify, and how we make further savings. And so very much part of what we do as a practice and how we talk about what we do as a practice is to be as simple and as clear and as visually kind of have as much visual clarity as we can muster as a practice. So this is very much along the lines, you can see that. And all these books, by the way, are accessible from our website and free to download. And another project that we've just finished with the NHBC and working with Bureau Happold and University College London is to look at how we can build competently and safely, how we can design safely in mass timber for residential buildings in the UK, completely within current UK building regulations. And we've done that by producing, again, 3 books. So the guide details of 30 different junctions across a generic 6-storey building, and the evidence that backs up those details and guide in order to receive a warranty from NHBC and a compliance with building regulations. So you can see examples here of some of those details. So each one of the 30 details describes a kind of junction across the building. So you can see the kind of, where the external wall meets the internal wall, where the roof works, where the party walls work. And the basis of this building is that it's a residential use building, that it's fully sprinklered, that all the timber is covered with plasterboard, and that it's below 18 meters, so 6-storey, typically 6-storey residential building. But we have a full letter of pre-approval from NHBC for this system. And the system includes that you can download offline. The system includes all those details, but with a full checklist as well of all the different products that can meet those individual details, and how those details go together, the construction process of those details. We're also doing an extensive amount of work for the EU. At the moment, we have about 25 million euros worth of European research funding. We've just finished Build in Wood, which is a technical guide to timber construction across 27 different regulatory environments. So you can imagine quite a lot of work in there. That was a 3-year project. We're working now on wood circles, which is how we design buildings for adaptive reuse, for reusing the materials and recycling materials, how we monitor those materials, and how we can manufacture and process those materials. So that's working with software manufacturers, with timber manufacturers, with local cities and developers to develop those kind of design criteria to enable reuse and recycling of materials. And now we're looking at a design guide specifically in architecture for timber construction across the EU. And that one we've just been awarded, so it's just started. Timber House, that's called. And then just to talk today about a specific project. So we have now 30 completed mass timber projects across France and the UK. This one completed at the end of 2022. People moved in beginning of last year. And this is the black and white building. And it's 5,000 square meters of co-working space for the office group, who are owned by Blackstone, who are a global investor. And so this building is in Shoreditch in central London. And you can see is a 6-storey building, so an 18-meter 1-hour fire building. And that regulation, that 1-hour fire regulation, has allowed us to have a completely exposed building. So the building from the ground floor slab up is entirely made of timber. So that's a timber frame made from LVL. So LVL is a laminate veneer lumber, and that's made from beech trees, from hardwood, from Central Europe, from Germany. Then we have CLT floor slabs, which are made from softwood, from a European spruce. The CLT also makes up the core, the staircase, the lift shafts within the building, and all of the connections within the building are exposed. So, they are spliced within the timber, so contained within the timber. So the timber is fireproofing all the steel connections within the building, but the entire timber structure is exposed throughout the building. So you can see the the truck arriving on the pavement outside the building, a very tight site. So no space really for any kind of set down or lay down areas for building materials. So pretty much everything at the second stage of the construction is craned into place. So you can see here each panel arriving with a specific instruction, a specific QR code onto that piece of timber, and being craned into position, accurately into position. So 893 individual timber components on the site. And from the ground floor slab up, the entire structure took 14 weeks to build. So we were 83 weeks on site, and that includes 20 weeks of foundation work and another 8 weeks of demolition in the beginning. So very fast and very quiet process. You can actually see here, interestingly enough as well, what we were able to do is that one of the things that we look to do is to reduce the amount of timber we use in all of our projects, so that we are constantly reflecting on how much timber we're using per square meter of building. We're thinking about how much timber we can save through an engineering kind of process. And that is that's very central to the design. So we have what is called an engineering-led process, an engineering-led architecture. And you can see one of the ways in which we've done that here is to include, is to rather than lay the floor slabs on top of the beams, we're laying the floor slabs within the beams of the construction here. So that allows the floor slabs to brace the structure. If you can imagine we have this lightweight LVL frame made from hardwood, and then rather than sitting the floor slabs on top, we're sitting the floor slabs within the structure itself. Sorry, there's some questions in the chat here. Yeah.
Jender's asked about planning. That's not necessarily related to timber, though, is it? But were there any planning issues with National Rail?
Yeah, there were. It was a nightmare. It was hellish. We had to give them lots of information about process, and lots of. So I've just got some external noise coming into this. I won't be one sec. I'm just gonna challenge that 1 second.
Okay.
I know, but you just ask them to stop shouting.
I know it's off-putting for you, but we can't hear anything.
Oh, you can't hear anything?
No,
okay.
No.
Yeah, it was really difficult with National Rail, and you can see that we have a party wall here, solid party wall against the building, but certainly we had to go through all of the kind of fire regulations with Network Rail, all the kind of demonstrations
Right.
of kind of like all the fire testing that
Yeah.
had been done. And so, yeah, it was quite challenging.
And just going back, Andrew, when you mentioned Blackstone being the owner of the building, I mean, what's the why behind this? Who chose to do it in this way? Is it something that Blackstone or the office group were looking for?
So
Or
the office group came to us
yeah.
to build them a low carbon building.
Mhm.
You know, the office group takes sustainability seriously, both in terms of their own internal kind of scope 3s and ESG requirements, but also I think that they, you know, and that's definitely part of the ethos of the company and of Blackstone, as increasingly of Blackstone, but also they're very aware that that building, a visibly low carbon building,
Mhm.
can, you know, can add value to their proposition.
Yeah,
So
absolutely.
you know, it in the US, in our projects in the US, the US development market is absolutely clear that that timber buildings are worth more, in especially within the commercial market. That
Yeah.
conversation in the UK is not as easy,
Mhm.
but certainly for TOG, I think that was a major driver, that they were, you know, that they were pretty confident that building a timber building would pay dividends for them.
Yeah, yeah, because Blackstone were obviously in a privileged position where they could drive change more quickly. That pace of change could happen quicker with Blackstone's input, I suppose.
Certainly, and it was office group driven rather than Blackstone driven,
Right. Yeah.
certainly.
Okay.
And you know, one of the high points for us is when we finished the building, Blackstone did a global advertising shoot where they put a photograph of the building on the front cover and said Blackstone is a sustainable developer, which is brilliant.
Yeah.
So, you know, you can see real change not only in the attitude of kind of other commercial developers who've been around the building, but also in Blackstone themselves in terms of understanding what benefits they can have. But we had to track for the whole design process of the building, we had to track the budget costs of the building against an equivalent concrete building. So we had to demonstrate to our client that this building would be cost equivalent to concrete.
Mhm.
And we were, in fact, about 5% more expensive, I think, ultimately than a concrete frame would have been, but we were significantly faster. So we
Mhm.
were able to bring the building to market much more rapidly.
Cool.
Which saved about 20%, about 4 months off the time.
And were those findings part of that 5%, or was that in addition, you know, the time savings that you
The
could
time saving was an addition.
Yeah. Okay, cool.
Yeah,
Thank you.
trying to get a QS to actually
Yeah.
quantify that is a challenge.
Yeah.
One of our challenges. But you can see here, so that you can see where the timber beams are spliced here in order to be able to take those connection details and to take those dowels that fix those together. You can see some of the labeling on there with the barcode as well. So we had 7 people on site for 14 weeks who'd built the entire structure. And you can see here as well, interestingly, where the beams are spanning further. Can you see my cursor?
Yeah.
So where the beams are spanning further, they're projecting up into the raised floor, so that the underside of the beams, the soffit line is the same, but the beams step up into the floor void depending on the spans. So you can see the kind of the care and the accuracy that this is going together. So you have a very different kind of construction site where you've got, you know, which is based on kind of accuracy and precision, and there's no, you know, bashing or banging or kind of toxic materials, or, you know, or kind of lines and lines of cement mixers down the road waiting to kind of like chugging away, waiting to pour cement into the site. And, you know, in its place, you have these kind of scheduled deliveries of timber, which are then accurately craned into place and screwed down. We have, further to that, opening windows throughout the building. The solar shading on the outside of the building, which you would have seen from there, the solar shading on the outside of the building allows us to have completely clear glazing. So we don't need any e-coatings on the glass because we have the solar shading that's preventing solar gain in the summer and encouraging solar gain in the winter. And that allows us to have completely clear glass. And there are a couple of principal benefits to the clear glass. One is that I think the difference in the environment that you have internal to the building, there's definite kind of health and well-being benefits to that. You know, you can tell what the day is like outside. Your body is, your eye is kind of has an understanding of the kind of circadian rhythms of the seasons, of the day, of what time of day it is, etc., which is much better for us. You know, the data is clear that people who work in environments with natural daylight and with natural materials have lower stress levels, have better attendance levels, are more likely to stay working for that employer. They get better faster in timber hospitals, they learn more quickly and better concentration in timber schools. So these sort of natural materials, natural light are a very big part of that design as well. And also the staircase here, you can see on the right hand side, so making attractive staircases that people want to run up and down, staircases that smell nice as well.
Iona's just picked up on the conditions. You seem to have fair conditions during construction, and she's asked if there would have been any damage to the timber from weather if the conditions weren't as good.
We had a good contractor and we had a great client who you know, who listened to us, thankfully, who took the specifications seriously and who followed our kind of, you know, who understood our experience and followed that. And so we were able to put in place, because of that, because of those relationships, we're able to kind of put into place proper plans for moisture management during the site construction. We were able to discuss with the timber subcontractor how they were able to sand off bits of moisture damaged timber. So where there was any moisture staining, and we did have a lot of rain as the building was going up.
Right. Okay.
You know, and so we have those systems very kind of clearly in place how to take care of those. And in fact, we've done some work with Swedish Timber, who have a really good set of moisture management plans on their website.
Right. Okay.
So yeah, it's not, you know, that's exactly right. The person that asked that question is exactly right, is that, you know, moisture management during construction and kind of mitigation of any kind of any effects of moisture on the structure, you know, any failures on the roof membrane, any failures in bathrooms or kitchens. That's the real key to detailing those buildings, is to understanding where those failures might occur.
Mm-hmm. Thank you.
And so you can see here, this is the kind of the ground floor foyer. And you can see the kind of natural light gives a very different kind of feeling, very different atmosphere to the building. Now, part of the process of the design of this building, the accreditations that we received, and also really, I think for our client was very important, was an understanding of what the implications were, clear understanding of what the implications were in terms of the life cycle analysis, the reusability of the building, the carbon analysis of the building. And so we carried out detailed reporting during design and construction, and then put that together in a report at the end of the job. Again, this is available on our website. And that covers stages A through D, and just to kind of set out what those are here for people to be clear. We do all of this in-house as part of our process, and we analyze all the elements of the building. So in this situation, analyzed all 14,630 elements of the building. We took the EPDs from each one of the 229 materials in the building, and we're able to really make design choices and material choices often based on that kind of knowledge. So the reductions that we were able to make in the design and the construction of the building begins to inform the architecture. So you have what we call like an architecture of sufficiency, where everything in the building is doing what it needs to do. There's nothing ostentatious here. There are no cantilevers. There are no kind of overblown forms or unnecessary kind of parts of the building. It really is a kind of, it really is driven to necessity and driven to an understanding and an enjoyment of the materials and the components that we use within the building. So we've managed also to quantify the amount of carbon that's stored within the timber. So I'm sure everybody understands that as a tree grows, performs this amazing photosynthesis, which absorbs carbon dioxide from the atmosphere, stores the carbon and releases the oxygen. So the carbon that's stored within timber within a European spruce tree, about 70% of the volume of the tree is carbon. And so we're actually able to quantify that carbon. And so about half the carbon that it takes to build the building is sequestered, is stored within an equivalent is stored within the body of the building itself. So that's 865 tons. Which gives us as I was saying before, a kind of into a minus figure. So in terms of our upfront carbon, our construction carbon, you can see here the basement at 28% is a massive amount of of the carbon in the building, and how the services, the decorations, the envelope of the building, and how the structure itself, which is usually the dominant part of any A1 to A5 calculation, is actually a relatively small part of the carbon. So about a 51% reduction from a concrete equivalent by using a timber structure. So replacing that structure, the lift shafts, staircases, the beams, columns, how we connect those details, and how we use the flooring composite in a diaphragm action are all very important. And then it's all about reducing the finishes, and the MEP, the solar shading on the outside of the building, allowed us to reduce the services in use by about a third across the building. And also by specifying reused raised floor, carpet tiles from recycled sources, reused furniture, that kind of thing. That also really brought down those B1 to B4 figures. And then looking at the potential within all of the materials for reuse and recycling, and so really designing for disassembly was very much part of the process of choice of materials. And so how we place ourselves in that, actually this is better now, because I think we've just nudged an A+ now with a full understanding of the report. So business as usual, just so people understand, is about 3 times what we were able to achieve with a black and white building. So business as usual around 1,400, 1,500, and we're at 500 kilograms per square meter of embodied carbon. So just understanding that actually that making these sorts of design decisions, building with these sorts of materials, really does make an incredible difference to what is achievable.
And that was on the basis that you brought this on a budget that was slightly, well, 5% you say there or thereabouts more than concrete, but not taking into account all of the well-being factors that you mentioned previously as well.
Absolutely.
It's not,
and also the increase in value. That Blackstone have written the increase of value up since completion, which is 18 months, and in 18 months they've increased the book value by 15%. The rental that they've achieved is 40% higher than their initial projections. So and we were 65% pre-let on the building.
Right. Andrew, I'm conscious of your time. There are some questions, but did you want to get to the end of your presentation?
I'm pretty much there, actually.
Oh,
so
right,
yeah, just there, cost equivalent, pretty much cost equivalent,
right.
and
right,
83 weeks. And that's the number of tree seeds that it took to grow the trees that built the building. Thank you.
That's a good image, that one there. Fantastic. No, very, very impressive. Not want to take up let's get.
Oh, don't worry, it's fine.
No, fine. I'm just thinking of going back, and Mario has a couple of questions. Mario, did you want to come off mute and just talk about the solar shading? Or unless you don't have a mic. Anyway, Andrew, you can see Mario's point there around shading done vertically, not horizontal.
So the building is a kind of the axis of the building is south-southeast and north-northwest. So on the back of the building, the solar shading runs horizontally, where it faces to the south and to the southeast, and this elevation of the building faces to the north and to northwest, and so the solar shading is vertical. And in fact, across the building, we have 16 different forms of solar shading across the building. So 16, including the depth of the solar shading, the orientation, the inclination. So at the back, they're tilted at varying rates depending on the solar kind of gain into the building.
Mhm.
And also the frequency of the solar panels, of the solar shades, sorry, around the building. And so we did that. I mean, one of the things I really love about these buildings is that the materials that we're using are, are really quite rudimentary, but the software that we use to engineer, to calculate, to sort of, the whole design process is incredibly, is using incredibly sophisticated software systems. So the BIM models that we're using in the office, they're migrating directly to the engineers, migrating directly to the factory. So the work that we're doing, the BIM models that we're drawing end up as the manufacturing drawings in the factory. So what we're drawing is what arrives on site. And that incredible accuracy really allows us to employ those materials in the best way.
Yeah, lots of detail gone onto it, as noted by Kingsley, who says great presentation, obviously industry leaders in the field. My point on that was it's great to see that you're willing to share all of your learnings, all the details, all of the guides, all of the evidence. And whilst I think you said that you've completed on 30 buildings across Europe and the UK, I wonder how many more have been completed using your inspiration and your details. I mean, that's
loads.
yeah,
Loads. I mean, the thing
exactly.
is, it's not like, if the guiding ethos of the practice is around climate change was a global issue, it's not, it really wouldn't be.
No, you're not looking to keep it to yourself. Yeah, exactly.
Wouldn't be
But
the
no,
right thing to keep it to ourselves, would it?
no. But I mean, obviously, from a positioning perspective, it's fantastic. But just what you're doing is great to see, because not
Thank you
everyone
very
would do
much.
that. Um,
In terms of maintaining the timber on the outside of
yeah,
the building, I should just say that the nosings for the timber curtain walling are aluminium. And then the solar shading itself is made from an American hardwood called tulip wood. And the reason why we use tulip wood from the US is because it's a hardwood which has suffered from climate change. A lot of them have been blown over, and so the Americans have a great store of this timber. We took this timber, we put it through a thermal modification process, and then it has a fire retardant in it. So it has a 70-year lifespan and a 30-minute fire retardancy in it.
cool. There's something here, Mario, blah, blah, blah. I was talking about sloped roofs, transparent or translucent sloped roofs that look like ordinary sloped tile tin roofs looking from the outside of the building.
No, there's no slope. Well, all the roofs are at a slope because all the CLT is at 10 degrees. And we ensure that we do that because, the lifespan of a single ply roofing membrane is what, 30 years, 25 years. And the lifespan of CLT should be, many, many decades of years. So we always ensure that the CLT roof slabs are at a full, in order that if there is failure in the membrane, then the moisture can track off the CLT.
Right. Okay. And Pablo had a question about CLT. Just sort of, he noted that you got the transition from structural CLT to exposed CLT, and what changed in the construction system and detailing.
So everything is all the CLT that you can see in the building is all structural. So everything that you can see in the building is a solid timber structure. There isn't anything that's covering anything else up. And so the honesty of the expression of the building is visible for all to see. So there really isn't anything in terms of a difference between construction and detailing.
Okay, cool. And also picking up on your point as well, just because you are using timber for the structure, you were talking about how you sort of designed in a way to save the amount of timber being used internally as well, and that was quite interesting to see that, like you say, planning, the amount of detail that's gone into this has been incredible. I suppose just one last question then, in terms of where you know, you're going back to 2008 when you first designed and built a building from timber to today. And then
2003 actually was our
2003
first
was
one.
it? Right.
Yeah,
Okay.
first little extension in 2003.
Right.
Yeah,
Okay.
21 years.
Yeah. And now we're only just
I
getting
was in shorts.
I'm still in shorts. I'm in Devon. I'm
Good for
always
you,
in
mate.
shorts.
You would want-
Human, you know, to today, where Human Nature and Phoenix Project are looking at sort
Yeah.
of the largest development, housing development using timber as a structure. It's taken like all of these years to get to that point.
I
So
know.
whilst everything that you've said is absolutely amazing and other people are copying, and the likes of Blackstone of championing that they're a sustainability developer, you know, and you know, you often see the number of cranes in a city as a barometer of economic activity. What's really interesting is you don't want to see any cranes because we want the structures to be built in this way.
Yeah.
What's holding us back? I mean, it's probably a rubbish last question, but I mean,
No, it's a great last question. It's the kind of often the last question that I ask myself every night. I don't know. I'm sorry to say I don't know. I will say that the UK, frustratingly, sadly, is one of the worst. We have probably the most relaxed legislation in Europe when it comes to sustainability. We have the least progressive planning laws around sustainability of any major European capital, which is shameful. Even in the US, the drive for sustainability in cities is greater than it is in the UK. And certainly the kind of architecture that we celebrate in the profession, but also, you know, in development and in planning, still has very little to do with sustainability. And that is not the case outside the UK. And I don't think that we only started working outside the UK at scale, you know, in the last 4 or 5 years. And we were really quite surprised by how far behind the UK was and how far behind attitudes here are. And, you know, we're all brought up with this idea that we're Great Britain and that we're at the forefront and all this stuff. It just is not the case. Either science, you know, either in terms of construction or really disappointingly in terms of architecture.
Yeah. Well, yeah, I didn't mean to end on a dampener because everything.
No, but you know, we
everything
can
you've
get
just shown
better.
is
It can
amazing.
only get
But-
better.
No, exactly. And also, well, obviously, you need to stand for RBA president as well, because you know,
That's not
if we
gonna
are
happen.
still judging buildings and sustainability doesn't really come into it, then
Well,
yeah.
hopefully Simon Baker Brown will stand again, and everybody should vote for him because he's fantastic. He's
Duncan,
magnificent.
yes, yeah,
Duncan
yeah,
Baker
yeah, yeah,
Brown.
yeah.
Yeah,
No,
sorry, he's brilliant.
absolutely. No, absolutely.
But you know, I think that on the bright side, you know, we've been commissioned by Network Rail, the Department for Education. We've done work for Department for Health, looking at how we can begin to employ timber construction, low carbon timber construction. We went to an HBC 2 years ago and said, look, we really need to change the way we build housing. We need to think about bio-based materials. And the NHBC were absolutely open arms, said, yes, we definitely do. And we want to be part of that change. So I think that, you know, a lot of attitudes have really changed quite fundamentally in government in the last few years, from developers in the last few years. So I think that change will be rapid. It's just been a bit frustratingly slow to date.
Yeah. But then it should be based on what you've just presented, and it's great for you to be able to share this with us, and this will be recorded, and I'll ensure that more people
Great, thank
see it
you.
and the people that attended, because it's fantastic work. So no, very lucky to have heard from you today, so appreciate that. Thanks for everyone for your
No, my pleasure. Thanks for the invite.
many questions. It's been a great session, so really do appreciate it, Andrew.
Great, my pleasure.
No, thank you very much. Enjoy the rest of your afternoon.
And you. Thank you.
Cheers, guys. Thanks.
Bye-bye.
Bye.